Good afternoon, good morning, good evening, depending on where you are, everyone. This is our second call of the COVID-19 and future of work and learning. Last time we started really with some brainstorming ideas. And while we're still developing a playbook to get engaged, one thing that I think we all agreed last time would be good to do to spark some knowledge sharing is to hear from folks who have volunteered. I'm really happy that Enrique Castro-Leon from Intel has accepted to actually go through some ideas about the connection between service science and cloud computing, and then in cloud, how it can play a major role in service innovation, and then impact of work long term. So without further ado, I'll turn it over to Enrique. He will be our conversation starter. And then the remaining of the call will have some time to not only talk about Enrique's presentations, but also to exchange some ideas as to how to continue really building our playbook of working together. So without further ado, Enrique, please take it from here.
Yes, so thank you very much. So the first thing I'd like to say is
oops. If you're not speaking, please put your.
So thank you for the opportunity to speak. So what I'm going to do today is tell you a story, right, of service transformation from my own personal perspective. It's a story that is still unfolding. It spans, I would say, at least 20 years of my career. The primary target has been the transformation of the Intel labs dedicated to platform development, so specifically server platforms. But it has been applied actually to healthcare, specifically Alzheimer's research. So I've been working with the GAIN project with the Alzheimer's Association since 2009. So GAIN is it's a federated database that tries to integrate the data coming from a number of labs into something that can be useful or can be made useful to other researchers. And so the methods that we developed internally within Intel, so we have discovered that they are also applicable to healthcare settings. And so I will touch on healthcare very much at the end, because this is intended to be a conversation starter, right? So I would like to encourage you to follow up and have additional conversations and hopefully this will spark some ideas from your side. I don't want to be too formal, right? So we are in a small group. So rather than having, well, maybe we can reserve the long questions at the end, but feel free to interrupt me anytime if you have any questions. So I don't want to make you wait. So any thoughts at this point? Okay. So what we're trying to do, right, and I'm an engineer, right? I started as an academician, but I've been with the private industry most of my career, so I try to be very practical. And so what we're trying to do here is not to invent radically new technologies, right? It's rather, we want to reuse the tools that we already have and recombine them, right, very, very quickly to accelerate whatever we do. In this case, our target is accelerating engineering workflows. And I think for this COVID-19 task force, I would say that the target problem would not be much different, right? Because we have a crisis, a pandemic crisis. And I guess as members of ISSIP, we would like to come up with something that works right away. Now, cloud computing, I would not equate cloud computing with service. However, I see cloud computing as the technology of the day, technology du jour, right? To implement some of the service ideas into something that works. And the reason being is because I would say it's probably a case of co-invention, right? Because cloud computing is intrinsically service-oriented. And so there is a natural alignment, right, of using cloud technology as a tool to solve problems that we have in front of us. And so the method that we will use is, in a way, very simple, right? So we see any human pursuit, right? Anything that we do as a collection of services that we can actually recombine at will in real time out of resource pools that are initially undifferentiated, right? And then combine those pieces or services into something useful. And so a pool is enormous, right? It's a big blob. And so the concept of workspace is very important as well to make things work, because we essentially use a common resource and then we try to make it our own. Okay, any questions? So just from level setting perspective, I'm going to start with the standard definition of service. So this came from, I guess, Robert Laas, right, a very well-known author in service space. And it's essentially trying to shift the focus from atoms into skills, right? So a service, in essence, is the application of any skill, right, for the benefit of someone, either ourselves or someone else. And so services are defined by the benefits. That a service is defined by the benefit that it delivers, right? Not the way it's implemented, not the things that it has within. It's just how well it works for a particular task. Yeah, and additionally, in order to be reusable, so we want services to be fungible, right? So we can retarget a capability to the widest possible of applications. And furthermore, they need to be easily available, right? Essentially available over a network. And that's why cloud computing is so useful, right, in service space. And so what do we do with it? Nothing mysterious, right? We want to keep doing what we do today, but faster. And that's the definition of agility. If we are doing something complicated and big, we want to be able to manage execution risks, right? Either during build-up or during execution or during operations. And in the process, we want to have some certainty, right? In the sense that what we plan to do gets done within the schedule that we set to ourselves. So those are the basic premises. And so in the case of Intel, so because I'm going to use the Intel platform Labs as the case study, right? The model, the business model for Intel is very simple. Intel as a company is a purveyor of technology, right? And you can say technology is actually the synthesis of the skills of the Intel engineers that are being put into practice. Now, Intel actually today is still very much, I guess, a goods dominant logic company, But through this project, I guess we're trying to plant a seed towards a more service-oriented approach. So any technology that Intel builds, right, the most common one that you can see is embodied into a processor, into silicon. And so the goal for Intel is to give this technology to integrators like manufacturers like Dell, Hewlett-Packard, right, that take those CPUs and then build computer platforms, PCs or servers out of that silicon. Now, the process for doing that is expensive, right? Any new generation takes about actually 5 years to execute. And so before any CPU sees the day of light, right, in the marketplace, we are dealing with prototypes, right? Engineering samples, CPUs, and then computers are having bearing the new generation of processors. And typically that is done through labs, right? And so the traditional lab is actually almost like a small shop. So 5 or 6 servers, right, in a departmental lab, that are used by the local engineers to do whatever they need to do. Now multiply that by thousands, right? So what happens is that now Intel ends up giving away thousands of machines to engineers just to do their own development. And the company has found that this is not sustainable, right? So that's a problem that we realized we had several years ago. And so as of this year, and probably accelerated by COVID-19, we are essentially transforming very rapidly towards a model where the machines are actually treated as pooled resources that are accessed through from the cloud. And then the last step for technology diffusion is again, the Dells or the HPs of the world, right, selling their machines bearing Intel technology to their end users. Yeah, what we found out is that, well, the processes that our customers use to sell to their customers and to develop their own platforms are actually not radically different, right? So this is another case of process reuse. And so that's another initiative that is in place, right? So there is nothing privileged in what we do from a service perspective, right? So if we can reuse any of the capabilities that we have, right, and another entity can take advantage of them, more power to them, right? So, okay, so how do we do that, right? So we need to think about how we build labs. So labs do exist in the cloud. And so we use the standard NIST definition of cloud, right, consisting of 3 layers plus cloud-based applications. So NIST is the US National Institute of Standards and Technology. Now, since we're dealing with atoms, regardless of, eventually we have to, right? We need a framework that allows to reframe those atoms into service, into a set of services. And so for that purpose, what we did was to essentially define 4 additional layers underneath the infrastructure as a service layer, which is actually software, right? Even though it's called infrastructure, it's still a virtualization layer. And so very quickly, right, so lab, right, is a bunch of machines in a room, right? But we had to think about that blob, right, in a more or less orderly way. So what we did was to abstract that lab into 4 layers, right? So every lab, starting at the bottom, right, needs a building, right? And that building needs to carry power and backbone networking, right? And then that allows us to, starting from the bare floor in that building, we lay out racks, instrumentation, and the networking that goes into each one of the racks. Once we have that, that allows us to deploy the machines. Right? So we're talking here physical machines, and this is essentially a bare metal service. So below that, it's the bare lab service, which is essentially a hosting service. And actually, these are entities that already do exist in the industry, right? So even though when you go to Amazon Web Services, you are renting a virtual machine. If you look hard enough, there are purveyors in the cloud that actually will rent you a physical machine. And then on top of everything, we have an entity, a bunch of software that allows us to manage these assets, physical assets, and spread them out across multiple entities. And multiple entities are very important. So that takes us to the next concept, right? So it's the concept of a service entity as a multi-sided platform. I'm sure many of you are already familiar with this concept, right? So it is not enough to have a service and then be able to use it once, right? It's essentially the same trying to clap with one hand, right? Yeah, it's possible perhaps, but there's nothing useful that you can do. So it gets interesting when you have a lab that actually it's a bunch of resources. Yeah, and we're talking not just one, two, we're talking about hundreds or thousands of machines, right? So such an infrastructure is very expensive, right? It takes hundreds of millions of dollars to build. And so the idea is that these labs carry multiple sponsorships. You have multiple organizations actually pooling their money to actually build a pool of resources that then get redirected to a specific target community. In this case, it could be the community of development engineers or future customers. So this is the foundation, right, for is what essentially needs to be a scalable and economical infrastructure that enables organizations to carry out their mission. Okay, so I guess you may have the next question that right. So, well, how do you build each one of these layers, right? So, service components are recursive, right? So, for the particular example of platform development labs, this is one possible decomposition. That's actually the decomposition that we use within Intel, right? So essentially everything has an API. That API may not be just programming, right? It could be a human API, right? So when it comes for a physical plant, for instance, your API is essentially a lease contract for the physical plant for a building. And so that negotiation can be done manually, or I guess in a cloud system, you can envision, right, lease negotiations that are done essentially machine to machine. And that can happen in more evolved environments. Now, a physical plant is not indivisible, right? It's not an atom. So that in turn, right, has other components like electric utility services, networking services, and so on. And so you can see that each one of the layers that we saw before is in turn composed of lesser services. And in fact, you can continue the recursive chain because instrumentation, well, we don't make it at Intel, right? We buy it from other suppliers. And so that by itself defines another tree behind each one of these boxes, right? And the same thing happens with the machines. And then for the managed labs, which is mostly software, right? We deploy software that some of it is internally sourced within Intel, but sometimes we purchase from other vendors. And also services need to be orchestrated. So there is a service clearinghouse, and then there is billing process behind the deployment of each one of the servers. So we need a service settler as well. But this is pretty much a constructive proof, right, of how you will build a very complex lab. And so for COVID-19, we can think of something, a similar approach, right? So we formulate ourselves one goal about what we can possibly do. And then we start looking around for pieces, right? Service pieces that we can eventually integrate into something consistent and meaningful. Okay, so I'm going to go into the actual implementation of the Intel lab system. So the analogy that I have is a used car dealer. So if you're not based in the United States, you may have heard about the CarMax, which is one of the largest used car dealers in the United States. And so when you go to one of their lots, right, you see essentially a big space, right? It's 3 or 4 blocks full of cars, right? And well, the first question is, which one do I pick, right? So typically, a customer would do essentially a little research ahead of time, and then that person will make a selection, right? And so essentially, that person is creating a little space of its own. And so the engineering labs at Intel are not much different, right? So any engineer in the community, right, can go to essentially a central portal or directory that has a listing of all the machines that are available. And so there are machines of all types, right? Not every machine is useful to every engineer, but there's metadata associated with it. And so any engineer, right, in the community can pick and choose machines here and there that may seem useful, right? And then essentially recast them into a personal workspace. And so that's essentially what the little lab shops today, right? Little departmental development teams, whenever they need a machine, they go to this pool and then carve out essentially a workspace. The mirror side is that this conglomerate of machines that you see here is not monolithic either. It actually represents about 50 organizations that have pooled their machines right into a single enormous pool. And so, of course, there are policies from within, and so it's at a first blush, right, is fairly complex. But if you're an engineer, all you see is it's essentially a flat, I guess, environment consisting of machines, right? And so if you click on any one of these machines, then you will see the policies, right? So whether you are allowed to actually reserve it, and for how long, and who owns it, and so on, and also the hardware profile of that machine. And also who has it reserving, if someone has it. But if someone has it reserved, you see the schedule ahead of time in the future, and then you can actually reserve that machine for a future date. Okay, so this lab did not happen in a haphazard way, right? Because actually it has deep roots in other technology trends that have been happening for the past 20 years. And that this is pretty much, I guess, my own personal journey, because the dark boxes are the areas where I had the fortune to essentially participate, or so even within Intel, I probably had 3 or 4 careers already, right, during my tenure. And so I've been a consultant, I've been a development engineer, I've been a software engineer manager, right? So early in the 2000s, I had been dealing with a number of technologies. right? So such as enterprise architecture planning, which is the discipline within IT, within information technology, that deals with strategic planning, right? So I used to be an architecture consultant. I used to develop code for high performance computing, right? And then my early exposure to services came from web services and then service-oriented architectures, which are an integral part of EAP. Now, I was noticing some tantalizing parallelism, right? And across all these range of technologies in the early 2000s, but they seem to be on the other side very separate developments, right? And that bothered me, right? So I did some research, right, from 2000 to 2005, and then came up with the concept of virtual service grids, which is essentially grid computing, right, combined with web services and SOAs, right? And I guess that gave me the excuse to write my first book. So that was published in 2008. And it so happened that it's essentially anticipated cloud computing by at least a year or two, right? Which is a separate development that had been going, I believe, within IBM at that time. And so there was a natural, I guess, inclination for VSGs to actually become, I guess, an implementation for cloud computing. And there was another development, right? So through Robert, right, I became aware of another discipline, which I think had its roots in IBM, which is essentially the distillation, right, of service disciplines. And so these two combined, right, led to the idea of cloud not just as an endpoint, right, for consumption, but also as a tool to build complex systems, right? And so this is essentially the idea for my fourth book, right, which was published in 2016, and it's essentially called that Cloud as a Service. And the actual application of this idea went into the Intel Labas as a Service initiative. And so what you see here are essentially components of the Intel Labas as a Service system, which is now called the Intel One Cloud system. And so it's being used internally and externally. So internally for our own engineering development, and then externally with ecosystem partners. And so what I anticipate, right, in the near future is that the partners that we work with, and this could be actually a healthcare partner, right, that will use some of these methods and make them their own, right, and start actually looking at it not just to become purveyors of atoms, right, but to actually wrap those atoms around services. And since those services embody a much more high value added capability, this will actually be beneficial for their business, right? Because they'll have the capability to turn on new revenue streams. And then once this processes become pervasive, there's no reason why they need to be rooted in two atoms either, right? So they can be disembodied. And so the last development that I see is that those services become entities on their own. And so we can envision cloud service providers or CSPs whose business model is actually to just become pure, what I call pure play service providers, right? And so they make a business by virtue of their skills and they use someone else's atoms, right? So so the end game is essentially an environment that is essentially what we call CI/CD, right? Continuous integration, continuous deployment. So there are no big bangs here, right? It's everything is in process, and that's another characteristic of and fundamental advantage of this service, of the service approach, which is we can do experiments very quickly, right? Because we don't need to have to wait 2 years to get the budget and buy a machine.
Hi there. Hey Frank, how are you?
Yeah. So in the
I don't like people.
Yeah. Do you have a question? Yeah. So what a service environment enables, right, is the ability to experiment and to fail fast. So we can weed out, right, all the combinations that are not productive. And so it enables entities that adopt a service approach, right, to evolve very, very quickly, much faster than any other entity that is still strapped to atoms. And so from an Intel perspective, this includes, I guess, OEMs, which stands for original equipment manufacturers, and original design manufacturers, value-added resellers, and system integrators. And so this is the beginning of the story, right? So next question is, how can we apply this idea to our, I guess, COVID-19 goals, right? So one way to start is to start thinking about how we can start carving out little workspaces where we can do little experiments, and then if we get something or an interesting result, right, we can regroup, band together, invite other people, and then continue. Because every entity that you see here, right, is actually a software entity. It exists in the cloud, and so you can launch it in real time. The other thing is that for COVID-19, very likely, right, every activity that we will do is going to be data intensive, right? Because we're essentially trying to learn very quickly. And so we will deal with results that someone else shares with us, and then we do something, and then we in turn turn around, right, and share that with others. And so workspaces themselves are not monolithic, right? They essentially draw resources from the cloud. And then this pattern is actually recursive, because if we move up, right, the the workspaces themselves are reconfigurable, are recomposable, right? So, for instance, for the first project I was involved, which is GAIN, right, with the Alzheimer's Association, the goal of GAIN was to merge, right, the data from multiple organizations into something coherent. Now, back in 2012, there was no precedent, right? So the first implementations were actually physical implementations, right? So one of the possibilities, right, being studied today is to actually accelerate this process through service entities. And now you can see that instead of having, right, the first instance, it took us 4 to 5 years, right? We started in 2009, and so the first launch was actually in 2014. And so today we can do the same probably in less than a day, right? And so that is the magnitude of agility, right, that we want to bring into play. Any questions so far? Okay, so where does that leave us, right? So by using a service approach, right, that ensures that we do everything only once, right? Especially when it comes to research and development, right, which is probably one of the most expensive human endeavors, right? If we can actually spread it out and reuse it, then that's going to accelerate, right, the collective progress. And so we do that through composite applications. So everything is recursive, right? So I was thinking that any piece that we do today, right, actually it's a nested set of services, almost in a fractal fashion, right? So if you open the envelope, you will see services inside. If you open those services inside, you will see more services and down to the real atoms, right? And so the flip side of that is that services are allowed to encapsulate technical processes and infrastructure. So to the extent that you don't need to be an expert at those processes in order to use them. And with the goal of reducing, right, the time to deployment and the associated cost of the underlying infrastructure. And then we can actually recombine those services in real time, right? So if something doesn't work, no problem. We just leave it there and then start over again. And that is not that difficult because we can essentially allocate recombine resources very, very fast. And then service gives us a common language, right, with which to reach out to other contributors. And then if we have common processes, right, reusable processes within our, I guess, mindset and philosophy, then that ensures that the benefits that we accrue, I guess, for our own work, right, can be used by the rest of the community. And so most of the work today, right, was actually intended to do platform development, but now we have, I guess, at least one case study where we reused, right, that knowledge, right, from a technology development space into a healthcare space. Okay, so with that, I think that was my allotted time. So I will entertain any questions that you may have, and Yasi, back to you.
Architecture is, or what next steps are or something.
Yes.
But what we
I was kind of curious, wait a minute.
Yes, please go ahead.
So this is Sunil. I have a question.
Yeah,
what is the business model behind this for Intel?
The business model is, well, this is a technical initiative, right? So I'm an engineer, right? So my goal is to actually make this work, right, and to accelerate, right, the technical workflows associated with, in this case, with platform development, and then to help our partners to do that, to do that faster as well.
Right. So maybe let me ask the question a little differently. So if if an ISSIP partner wanted to leverage this, how would they go about doing that?
In a small scale, right? I guess we will have a conversation, and then if it comes to scaling it, right? There's a lot of documentation internally already, right? So we would put together maybe a working group or a task force. So because my dream is perhaps, well, there's a significant body of knowledge here, so maybe there's an opportunity to put together a special interest group, right, in the industry, right? I tend to think in terms of open source, right? So this is something useful, right? Like Linus said back in 1994. So if you feel that you can use it, more power to you. I'll be more than glad to talk with you, and let's roll up our sleeves and let's start working. Yeah.
Okay, thank you.
Yeah.
Hi, this is Larry.
Hi, Larry.
In listening to all of this, I'm thinking about this particular group and the reason that we have been brought together, and particularly in the light of the pandemic. This seems to be able to address two areas of that. One is within the context of the pandemic, how is information that is developed in all these little different places and research labs and just all over the world, Are people replicating what other people are trying to do? Are people either for basic science or for very specific kinds of cures or vaccines or any of the other studies, epidemiological studies that people want to make? So that's one area where I see this infrastructure being of great use, where all of the different work groups can come in and see and share and have a platform for that. The other one is part of my understanding of this group is what happens essentially post COVID-19 or when it's on downturn. How have business practices been impacted? How have educational practices been impacted? How has healthcare been impacted? And does a common platform with multiple kinds of workstation, work group capabilities supporting those and sharing, when allowed, sharing information across teams, how will that help our world change using COVID-19 as a disruptive factor? Are those, so during COVID, post-COVID, are those, do those make sense to other people?
Absolutely. You may have a project in mind, right? But you say, oh, I cannot do it because I need machines, or I need this, I need that. So this methodology can frame that project, right? And give you resources to execute. So in fact, many of these machines that I deal with today, every day, are in the cloud, right? So you may need a platform, right? That may be a powerful platform to run certain simulations. We can essentially make that machine available to you over the cloud. And in fact, we have a case study, right, for COVID-19 already. I've been working with Rodrigo Barnes, right, for the past couple of years. And he has been working, I guess, in Alzheimer's space, right? So he can give us essentially another data point where we can use this methodology for a healthcare capability. So Rodrigo, please go ahead.
Yeah, I just, hopefully you can hear me now. Yeah, so Enrique asked me to kind of sit in on this call because we've been working on a concrete example of what he's been talking outside the Intel context. So as a kind of continuation of the GAIN work, we've been looking at a global network for Alzheimer's disease. This is a kind of an currently in a kind of a private beta funded by the Gates Ventures. And it's been looking to develop, we've been working between the US and the UK, but actually the idea is to connect up and bring together researchers in these kind of workspaces and reutilize and pool as necessary fairly dynamically these cloud-based resources. Now, the really interesting thing, and I think the reason maybe to go for some of the more abstracted presentation of that kind of technology is that it's allowed us to now reapply this to a COVID-19 situation. So we're developing a version of the same model, but in a COVID-19 thing. That's still in another in a kind of a confidence building stage. And I guess one of the things a couple of things that I think we're to touch on the point that was made earlier was how do you shift some of those collaborations to another level? So by bringing together people who maybe practically would find it hard to share data, to share knowledge through some of the kind of codifying that Enrique pointed to. But also, how can you do things there's a lot of exercises with open data right now. So there's a lot of great willingness to share data, which is great. But specifically, the thing we've been targeting in COVID-19 has been, what can you do with very privileged patient data, early stage clinical trial data, vaccine trial data, and also healthcare system data. And you can only really do this by having the kind of federated approach that Enrique mentioned. And so we, things that we've learned from the Alzheimer's space, we're now trying to apply in the COVID space and see if we can accelerate some of that. And I think so far the evidence has been that we have been able to accelerate some of those flows, to use Enrique's language. So yeah, I mean, I think I can try and answer some questions if anybody's interested in the specifics, but yeah. So I'm not a service person. I'm an engineer, but I'm not a service science person. So I'll talk in more my language. But
yeah, this is Gopi. So just to add on a few points. So this foundation acts as a a framework for deploying and usage of new technologies and solutions which Intel develops. For example, in the area of AI, artificial and machine learning, in the brain tumor prediction, genomics, and others, automated solutions, libraries, and frameworks can be deployed. So that way is a great way in order to showcase all the technology which Intel produces also.
Yes, so what you see here is another example of accelerated evolution, right? Because a service approach allows to any researcher, right, to go over several generations of experimentation, right, in a fraction of time that it will have taken to do it using physical things.
My question to the Intel colleagues is that what would success for this project look like when you look down the road? Does the question make sense?
Yes, so in my simple mind, there are two approaches, right? You can approach it bottom up or top down, right? So bottom up is represented by the question, can we find a small project that we can do together, right? And demonstrate A. And then if that project is successful, then we make it a little bigger, or we get together with other similar projects. Top down would be would be having a grand plan, right? That perhaps a larger budget, and then drive change, right? On the basis of that, and in a way that is not better or worse. It's another way of doing things. So if we have, for instance, a big sponsor with a big goal, then we can do that. We can use that approach. Or what's often used in software engineering is, I guess, top down, bottom up, and meet in the middle, because that usually is the path that with least complexity.
And a follow on to that question, the stage that the project right now is within Intel, would you say it's in proof of concept, post proof of concept? Can you say a little bit more about that?
It's in execution and scaling, right? And
Right.
It has accelerated enormously because of the COVID-19 crisis, right? So
Okay.
it enabled, work at home policies, right, across, I would say, probably thousands of engineers. Right? We're talking about perhaps 10,000 engineers with an investment of close to probably $5 billion per year in research. Right?
Oh, wow. Okay.
Yeah.
All right.
Yeah, and then also this lab framework, for example, I use the servers day in, day out. Within just half an hour, I have the infrastructure what I want. I can just go and start, running some workloads, characterize it, and optimize it quickly. Earlier, I used to think about, oh, gee, I need to buy this system. It'll take a week or two to assemble it. Now it's just instantaneous. That too, for internal usage, I can get the state-of-the-art machines and technologies right away. So, which is pretty time saving for us, right? So that's monumental.
Excellent.
So this is Sunil, possibly a dumb question. How is this different from what you can get on the public cloud providers like Azure or AWS?
Yeah, the cloud providers stop in the middle, right? At the infrastructure as a service layer, right? So in the particular case of Intel, we were dealing with new platforms, right? And so a virtualized platform is not useful for engineering development when you are designing the machines themselves. And so this is essentially a bare metal service. Now,
so you're, Enrique, sorry, you're saying that basically the chips, the boards, some of them are quite experimental, and they're not
yes.
like your standard out of the box kind of
right, but
standardized VMs, hardware, sorry.
Exactly. But for COVID-19, what may be useful is you may have a particular workload that requires a very powerful computer, right? That maybe it takes weeks to run. And so you may be able to reduce the runtime to hours, right? And so for that application, it may be useful to have actually access to a real physical machine. And that's what we provide. And in fact, you can do it with one of our protocols.
I gotcha.
Yeah.
Yeah.
Okay.
That,
Okay.
yeah,
So that's actually really helpful. Sorry if I missed that early on. That's really helpful. So you're providing a level of compute power here that's just very different.
Yes.
right. Because in the cloud, you see only production release systems, whereas within the dev, cloud environment here, you see the state of the art technology as the platform being developed. I can run my emerging class workloads on a cluster in the lab directly, the latest technology in development. So that's the, key benefit.
Right. Got it. Thank you.
Yes, so as a next step, as an engineer, I tend to go bottom up, right? So you might want to think about a project, right, that could be doable, right? And maybe let's have a group discussion about that project and then brainstorm on how to actually make it happen. Right? And since I'm not a healthcare expert, all right, it has to be something that I guess if you work in a clinical setting, right, something that is bugging you, right, that we could do, and to improve the plight of the community.
Can I ask a question to the group? Kind of maybe to stimulate. One of the things that we're finding, we work mainly in healthcare, and also with this federated approach, one of the key things is to encourage organizations to present an interface, to play with a standard. That could be the standard we developed for federated research, or it could be a standard like FHIR, which a lot of US hospitals are starting to adopt. And sometimes organizations find it hard to kind of expose that. Is that a trend that you see in your settings, particularly in healthcare or maybe in other settings? There's a kind of a risk taking involved in doing that.
Yeah, I've worked in and out of healthcare for many years. Pardon me. And you're right, it is. Also, I was a patient in the United Health Service in Liverpool several years ago, and I could see the differences from inside of the private kind of healthcare system versus a very public healthcare system. And in the private healthcare system, it is, in the United States anyway, it is still competitive. And it is still a matter of, there's some collaboration that goes on, and yet there's still distinctions that certain healthcare, whether the big group or their small clinics, they still want to have some differentiators in there. And you're right, it does, that intellectual property that's developed by the healthcare system, no less pharmaceuticals and treatments and all of those, are certainly competitive and in a capitalistic environment. What I have seen with the COVID is, of course, it's so worldwide, and it's so not only pervasive that way, but pervasive down to the level of people that have been affected or have died, that it has pressed people into a more philanthropic, altruistic framework where they're ready to share data at this point. And yet, I heard on the PBS NewsHour last night, our public broadcasting system, they were talking about how vaccine development is the hottest commodity in the world today, and how the report was saying how Chinese hackers have been instructed to target anything that has to do with vaccine development anywhere in the world, and to be able to grab it and take it for use there. So I think we've got those competitive systems, probably something that you've run into with Alzheimer's research. And not only that, we've got HIPAA here in the US and other sorts of legislation around protecting the privacy of personal information. So I think those are some of the factors, but I think they could be overcome with the right questions.
Yeah, I think this is Sunil. The other dynamic that's happening in U.S. healthcare is the CMS, which is the Center for Medicare and Medicaid Services across the U.S. It's a governing body. They have now dictated that patient health data is owned by the patient.
Mm-hmm.
And they've published a set of standard APIs that healthcare providers are being forced to comply with. And the concept behind that is they want companies to build apps such that I, as a patient, have access to all of my medical and pharmaceutical data. And that then gives me a certain degree of portability and control, right? So there's actually a massive opportunity emerging in that space. Not all of the providers have bought into it yet because it's still early, but you can see that trend picking up. And I think there might be some use cases there worth.
Yeah, no, we work exactly in that space with, for example, Great Ormond Street Hospital. It's a children's hospital, and they want to exchange basically machine learning based apps between Boston Children's Hospital, their hospital in London, and Melbourne Children's Hospital. And the only way they can do that is by having a level of compatibility and standard interfaces. And the interface you mentioned, the FHIR interface, it's called, is one of those key things. So it's, I think one thing people forget is the ecosystems are competitive. There's nothing wrong with that. But you have to buy into the idea of playing the game. And I think that's a big shift for a lot of organizations, which I think, and I think to your point, Larry, the international dimension is really important because you can often find a collaborator somewhere else and make progress with that. Whereas maybe in your own backyard, it's a little bit too tight. So, yeah.
Well, one of the, sorry, go ahead.
Yeah, go ahead, Sunil. No, go ahead.
Yeah, I was just going to make one final point. I think what you'll also find is companies that provide the hospital operating systems, the EHRs and the AMRs, are starting to play in this space. In fact, Cerner, which is one of the largest ones, has a product offering of exchanging data. They call it Healthy Intent. You should take a look at that.
Yeah, we partner with Microsoft, and they have a kind of a neutral one that scales at cloud level. So that means we're kind of independent of. So we're one of those kind of CSP, virtual kind of layer on top of that. But I think all sorts of models and business models are possible within that.
Yeah.
It's a really dynamic space. Yeah.
I want to ask a question, especially Sunil, not to put you on spot, and Larry, who have been more involved in ISSIP, and Ralph. What do you guys see, or Amar actually, what do you guys see about the connection point between what Enrique presented and next steps of the goal of the working group?
Yeah, I tell you, Yasi, I'll jump in. That's kind of what was going through my head. I don't have a clear point of view on that yet.
Yeah, unfortunately, I don't either.
I need to think about that a little bit, right? Because I just need to think about it more.
Yeah, and maybe I'll have a call with Enrique offline if you want, Enrique.
Anytime.
But,
well, I could see, Yasi, to answer that from my perspective. Certainly a service platform serving the needs of people who are today working on COVID-19 mediation, and then in the future, people working on the culture and the mode of work, the future of work, all of those things eventually. Either one of those will have hypotheses that they want to test, across different groups. And I could see where this kind of a universal platform could offer a way of hypotheses gathering, and testing and sharing results in that area. So I see that as one area as a service to the research and academic communities.
Who are involved in the COVID-19 research, right? Yeah, I was thinking actually, if it is helpful, Enrique, we have some colleagues from Mayo Clinic who, we could certainly, that would be a point of connection.
Yes, maybe I'd like to suggest that Rodrigo join us as well, because he's actually working in that space.
Yeah, so we can.
See, John Halamka has just moved to Mayo, and he from Beth Israel, and he's been really instrumental in some of these interoperability frameworks.
Yeah, so I'll be happy to make that connection. But I think, we're 1 minute over. We should keep thinking, I think, on those connection points. Thanks, Larry, for that input. All right, well, thank you so much, everyone. We'll have our next call in a couple of weeks with another speaker. Okay, thank you so much. Thanks, Enrique, for a wonderful presentation.
My pleasure.
Enrique,
Talk to
thank you.
soon.
Bye-bye.
Bye-bye. Thank you.
Everyone.